Hello, good evening, everyone. Uh, Welcome to the week 4 of the Principles of Signals and System course. This is a tutorial session of the course of Principle of Signals and System, which is taught by Aditya sir on NPTEL portal. So today we are going to discuss about some questions based on week 4, whatever he taught in the NPTEL portal. And so the student who is not able to watch now, this video will be uploaded on YouTube and the link will be shared in NPTEL. So today we will discuss concepts of Laplace transform and we'll do lots of practice question based on that. So first we will see what is Laplace transform and what is the formula for the Laplace transform. So let's suppose any function is given. Just wait for it. Let's suppose any function is given ft. So the Laplace transform of ft is given as integration over minus infinite to infinite ft into e to the power minus st dt, and this is also written as fs. So the Laplace transform of ft is fs. So we can write in this way. So this is Laplace transform, and also we can do inverse Laplace transform. So we can find ft from the fs. So there is one more concept here, like we have to find the region of convergence for this Laplace transform. So like region of convergence simply describes the region of the plane, or basically the range of value of S where this Laplace transform exists. So just it should converge. So S is equal to here sigma plus j omega. So we will see various properties how this uh, value of sigma and all can be determined for the whether the system is stable or not. So for the existence of Laplace transform, this condition should be true. For existence of Laplace transform, it should converges in the region of convergence. So integration over minus infinite to infinite ft e to the power minus sigma t mod of that dt is less than infinite. So it defines the ROC. So we will see various basics signals and we will find their Laplace transform. And after that, we will also solve some tough questions as well. Sir, Yeah, hello. T is mod T into the power of minus minus sigma T or minus ST. This is for minus sigma t because we are taking with respect to sigma only. Like later on we will discuss, there are different region of convergence. So that on the x-axis it is sigma, and this is j omega, the imaginary axis. So it depends on the value of sigma only, the region of convergence. And if j omega come in the region of convergence, this means that signal is stable. So this imaginary axis is for stability and the real axis is for region of convergence. So like we'll take the basic signal, that is xt is equal to e to the power minus at ut. This is the most simplest one. And we'll try to find the Laplace transform of this. So just we'll use the simple definition, the formula of Laplace transform. So the Laplace transform of xt, that is written as xs, is equal to ft into e to the power minus st. So here is ft is e to the power minus at. If you remove this ut, then the integration will be from 0 to infinite and ut will become 1, e to the power minus st dt. So after that, when you take here, you will get minus a plus s into t dt. When you simplify this, the integration will be e to the power minus a plus s t divided by minus a plus s, and the lower limit is 0 and the higher limit is infinite. So when t is infinite, and let's suppose our a plus s is positive, then only uh, the signal will converges. So then the value will be 0. When t is 0, then it will be 1 by final answer is 1 by a plus s. But there is one important thing, that this integration will converges only if this a plus s is positive value. So this integration, someone join now, so I'll explain once again. So we have taken the basic signal e to the power minus at ut and try to find the we have taken the basic signal e to the power minus at ut and try to find the Laplace transform of this. So we have used the formula of Laplace transform, that is ft into e to the power minus st dt integration over minus infinite to plus infinite. So after doing this integration, we got this value e to the power minus a plus st divided by minus a plus s. So this will converges only when, like when you put t is equal to infinite, then if a plus s is greater than 0, then only this value will become 0. So our a plus 1 should be greater than 0. So this means real part of s plus a is greater than 0. Real part of s is sigma, because s is our sigma plus j omega. Sigma is the real part and j omega is the imaginary part. So in this case, sigma is greater than minus a. So let's suppose if our value of a is like something 2, then the region of convergence is the right side of minus a, because sigma is greater than minus a. So in this way, we have to find the Laplace transform, and we will see some of the properties of Laplace transform. That will be very, very useful while solving the complex questions. So the first is, let's suppose if you multiply with e to the power minus at into ft. Now if we do the Laplace transform of this, the value will be fs plus a. Means if Laplace transform of ft is fs, then the Laplace transform of e to the power minus at ft will be fs plus a. So in the same way, if it is e to the power at into ft, then the Laplace transform will be f of s minus a. And one more property is there, like let's suppose if we are delaying the signal, like uh, if we are delaying ft minus t naught and then we are doing the Laplace transform, in that case it will be simply e to the power minus st naught into fs. And also the linear property of Laplace transform states that, like if let's suppose one signal is f1t and its Laplace transform is f1s, another signal is f2t, its Laplace transform is f2s, then when we multiply with some constant like alpha into f1t plus beta into f2t and we find the Laplace transform, the value will be alpha f1s plus beta f2s. But when you talk about the region of convergence, then let's suppose this signal have region of convergence, some region R1, and this have some region of convergence that is R2. Then the region of convergence of this signal will be intersection of both the regions, that is R1 intersection R2. Now, if we have to find the whether the system is stable or not by uh, checking the region of convergence, then we know that a system is stable when the integration of ht dt is less than infinite. So, uh, for causal system, we know ht is equal to 0 for t is less than 0. And as you have already studied in this week, that the pole does not lie in the region of convergence. Pole can be the boundary, but pole does not contain ROC. So poles only form the boundary of ROC, form the boundaries of ROC. It does not contain. So let's suppose uh, we have a right-sided ROC. Means this means the region of convergence is right-sided. Means this some value is alpha. In that case, if region of convergence contain j omega axis, then the signal is stable. So we'll solve some question and then we will see. So let me take some question. Find the Laplace transform of xt is equal to e to the power minus t plus e to the power minus 2t into ut. And the second part is xt equal to e to the power minus t ut plus e to the power 2t u of minus t. So for this, we will use this linearity property, what we have studied here. So in this, we know that it is a summation of two function f1t is e to the power minus t ut and f2t is u to the power minus 2t ut. So in this, we know that the Laplace transform of e to the power minus t ut is 1 by s plus 1, and here the region of convergence, that is real part of s, is greater than minus 1. And for this, the Laplace transform is 1 by s plus 2 and region of convergence, that is greater than minus 2, because both are right-handed signal. When you draw, you will get uh, both the signals are right-handed because it is multiplied with ut. So for value less than 0, it will be 0, and at t is equal to 0, it will be 1, and after that, this will be the curve of e to the power minus t ut. So now when you add both the signals, so the Laplace transform of this will be 1 by s plus 1 plus 1 by s plus 2. Now we have to find the region of convergence, that will be intersection of these two. So that is region of convergence of this xt, like this will be equal to intersection of region of convergence of both the signal. So for the first signal, the region of convergence was greater than minus 1. So this is minus 1. For second signal, it is greater than minus 2. So what will be the combined region of convergence? Like the intersection of both, that will be this part. So this will be greater than minus 1. We can sum it, and it will be like s plus 2 plus s plus 1 by s squared plus 3s plus 2. So this will be 2s plus 3 divided by s squared plus 3s plus 2. So this is the answer for the first question. In the second part, here it is u to the power u minus t is there. This means the unit step function is reversed, and for this we have to find the Laplace transform. So we will see how to find for this. xt is equal to e to the power minus t ut plus e to the power 2t u of minus t. For this, we know that for e to the power minus t ut, the Laplace transform will be 1 by s plus 1, and for e to the power 2t u of minus t, for this the region of convergence is greater than minus 1, because this is right-handed signal. E to the power 2t u of minus t, the Laplace transform will be minus 1 by s minus 2. So, and here this is a left-handed signal. So this signal is like this. When you draw on the graph, for t is greater than 0, it will be 0. For t is equal to 0, it will be 1. And after that, when t is minus infinite, it will decrease up to 0. So this is the curve of e to the power 2t u of minus t. So you can find this Laplace transform with the basic formula also. Like we can you can do u to the power e to the power 2t, and here integration will be minus infinite to 0, and then e to the power minus st dt. This integration you can do, you will get this same value. So the reason of convergence of this will be, that is s minus 2. So like the real part of s minus 2 should be less than 0. So it will be alpha is less than 2. So here the region of convergence is less than 2. So what will be the intersection of these two? This is greater than minus 1, and let's suppose this is 2. So this is less than 2. So this area is the region of convergence, that is minus 1 to 2. So the xs will be summation of these two, that is 1 by s plus 1 minus 1 by s minus 2, and the region of convergence is minus 1 to 2. So in this way we can find this very simple question. The, it is the real value of yes, right? Not excess. Minus 1 less than. Yeah, that is just the region of convergence. You can denote it by anything. Just I have written the function name, so you can write RE of S also. So now we will see some other properties. Like when the signal is multiplied by time. Like, so we'll write multiplication by time. All these are already taught in this week lecture, so I'm just writing the summary of it, not going into the deep. And you can see the proof. This is already taught in the NPTEL portal, the lecture uploaded there. So the Laplace transform of ft is fs. So when ft is multiplied with time t, so the Laplace transform will be minus of differentiation of fs with respect to f. And if we multiply it with t to the power n, this is a generalized term. So this will be n factorial by, if we do multiple time, then we will take some example, then we will see this how to do this. And also we will see like when the time differentiation property. So So in this, if the Laplace transform of ft is given as fs, then when we differentiate ft with respect to time, then the Laplace transform will be sfs. And if you differentiate it n times, then it will be snfs. So whenever equation is given, like in this term, like let's suppose a2, we have to find the transfer function in such kind of equation. It is derivative of order 2 plus a1 d of yt by dt plus a naught yt, that is equal to b1 d of xt dt plus b naught xt. So for such thing, first we will find the inverse Laplace transformation, and then we will find the transfer function. So we will do this. So like when you do this, you will get that a2 s square of ys plus this will be a1 s of ys, and this will be a naught into ys. In the right hand side, it will be b1. It is differentiation is one time, so it will be s of xs plus b naught xs. Now, when you take ys and xs term common, you will get a2s squared plus a1s plus a naught is equal to, when you take xs common here, it will be b1s plus b naught. So the transfer function hs is given as ys divided by xs, that is equal to a2s squared plus a1s plus a naught divided by b1s plus b naught. So in this way we can find the transfer function which is in the derivative order. We can see some other properties also, whatever is taught in this lecture. We have already seen the time shifting property when the ft signal is shifted with t naught, then the multiplication will be e to the power minus st naught. There is one more important thing, like this time differentiation property, this is for the bilateral Laplace transform. But when the signal is having unilateral transform, this means that is from, like when we find Laplace transform, so we write ft e to the power minus st dt. This is, if it is from minus infinite to infinite, this is bilateral Laplace transform. But when it is from 0 minus to infinite or 0 to infinite, so it will be unilateral transform. This means the transform is for one side of the axis only. So this is for the bilateral transform. We'll see for unilateral also. So for unilateral transform, time differentiation property can be written as Let's suppose the Laplace transform of ft is given as fs, then the Laplace transform of dft by dt will be given as sfs minus f of 0 minus. So this is the initial value of function f, that is at 0 minus. So any signal fs can be, therefore ys can be represented as y of 0 state response plus 0 input response. So this is 0 input response. This means this only the value of this will come with respect to considering the initial condition only. So this is 0 input response considering initial condition only. Like this is useful in the inductor and capacitor in the network theory course. And this is 0 state response, which this depends on the input. So this assume that initial condition to be 0. 0 state response with input only, considering initial condition to be 0. And now this, if the derivative is of higher order, like d square ft by dt square, then for unilateral transform, it will be s square fs minus s of f0 minus f dash 0. And if it is of order 3, like d3ft divided by dt cube, that will be s cube fs minus s square f0 minus s f dash 0 minus f double dash 0. So these formula are applied when some initial condition are given, like in inductor and capacitor does not allow the sudden change in current and voltage. So in that condition, these are used. Like that is just see, this is initial condition. Like this is 0 from here the signal started. 0 minus is just below the, like that is the initial condition just before the time started. That's why we have written 0 minus. So F0 means? 0 means like F0. This is just a time. So F0 is the initial condition. It is just before the F0 is the starting condition. F0 minus is the initial condition just before the starting. Okay, okay. So using this, we can also find the initial value and final value. So there's two theorem, that is initial value theorem. So this is a complete summary of Laplace transform. Using this formula, you can solve any gate problems. So in initial value theorem, like if we have to find the f naught, that is f0, so this is given as limit of s tends to infinite s into fs. And similarly, there is final value theorem. In this, if we have to find f of infinite, that can be found as limit s tends to 0 s into fs. So there is some requirements, that is initial value theorem applied only when that is a proper fraction, like degree of numerator is less than the degree of denominator. So initial value theorem applied only when degree of numerator is less than degree of denominator in the transfer function. And for final value theorem also, it can be applied only when f infinite is defined and all pole of Fs lie in the left half of S plane. So whenever all the poles lie on the left half of the S plane, this means that signal is stable. So it will not be applicable for unstable signal. So all poles of Fs lie in the left side of S plane. So now we can solve some question based on whatever theory we have studied today. So I will take some question from the gate book. And also there is one very special property when there is two signal, that is the convolution in time domain, like x1t convolution x2t, that can be easily found using x1s. Like you have to just find the Laplace transform. In Laplace transform, it will be after finding Laplace transform, you can simply just multiply this signal. The Laplace transform of this signal will be simply just find x1s, x2s, and just simply multiply it. Now we'll take one question based on this. Find the Laplace transform of xt equal to minus e to the power 2t ut convolution with t into ut. So whatever properties we have studied, we will apply this. See here what and all property we can apply. Here is the convolution, so this property we can apply, and also you can see time is multiplied with signal ut, so we can apply that multiplication with time properties as well. So we'll apply both the property. So now we know that let's suppose this is our x1t and this is x2t. So it is simply x1t convolution with x2t. So we can find the Laplace transform of this. First, we'll find the Laplace transform of both the singles individually and we'll just multiply it. That will be the Laplace transform of xt. So, x1s is equal to, this is minus e to the power 2t ut. So, it will be minus 1 by x minus 2. And x2t is equal to t into ut. So, we know that for ut, the Laplace transform of ut is 1 by s. And we have also done for time, when the signal multiply with time, it will be d of minus fs ds. So we will do minus of, so this will be 1 by s square. So we will simply write here the Laplace transform of, that is x2s, that is equal to 1 by s square. So now the Laplace transform of xt that is equal to x1s into x2s. So this will be 1 by s square s minus 2. So this is just a simple question. Yes, simple is there, right? I x1 is 1 by minus 1 by s minus 2. Where? X1 is minus 1 by s minus 2. Yes, yes, minus. Here minus symbol will come because x1s is minus 1 by s minus 2. So now we'll take some other question. Before that, we will see one more property. We have already seen that time shifting, like when we are doing time shifting. Now we'll see for time scaling also. So the time scaling property of Laplace transform. So in this, what happened? Whenever, uh, if suppose the Laplace transform of xt is xs, so now when t is scaled with a, that is x of at, the Laplace transform will be 1 by mod a x of s by a. So now we'll solve one question like that. That includes everything: uh, time shifting, time scaling, and time reversal. Everything. And also for time reversal, like this, write this. If the Laplace transform of xt is xs, then the Laplace transform of x minus t will be x of minus s. So we'll solve one question like find the Laplace transform. This includes all these properties. U of minus 2t minus 1. So we have to find the Laplace transform of u of minus 2t minus 1. So we'll start with basic first. Like we know that the Laplace transform of ut is 1 by s. So we'll start from here only and we will use all those properties. So first we will do time scaling, that is Laplace transform of u of 2t. So this will be, as we know that u of t is this curve, and when you do u of 2t, this will be also the same, like u of t and u of 2t both are same only. So the Laplace transform will be also the same, and this both the signal have same region of convergence also, because when you do, the region of convergence will be greater than 0. So both have everything same. So in that case, the both signals are same signal. So for u of 2t also have the Laplace transform as 1 by s. Now what we will do, we will do time shifting, like we'll shift t by minus half, like shift by half. Then we know that when it is shifted by like half, then it becomes e to the power minus as. So in this case, the Laplace transform will be e to the power minus this half into s and 1 by s. So now u of 2t minus half, this will become 2t minus 1. So what we have to find? We have to like 2t minus 1. So we have to just reverse the time. Then it will become minus 2t minus 1. So now we will do time reversal. So that is u of 2 minus t. Just we'll do the time reversal and nothing much. Minus half. So for time reversal, we know that we have written here x of minus t. Just we have to substitute in place of s, we have to substitute minus s. So it will become 1 by minus s e to the power minus half minus s. So the final answer will be minus 1 by s e to the power s by 2. So in this way, we can use all the properties and simplify the Laplace transform easily instead of solving and taking lots of time. Sir, this is just some confusion. You said that u of 2t and u of t has the same Laplace transform. Yes, okay, yes. Means that times on unit function. Yes, yes. Okay. Then the original function u of minus 2t minus 1, it is simply which one you do first, right? So first shifting, then scaling, or scaling first and then shifting. Uh, like we can see according to like how easily we can come up to the final value. So first I have done this time shifting. We can do anything. Whatever is easy, we can do that. So this is time shifting and after that time reversal we have done in this case. Also we can do time reversal and then shifting. But if you do time reversal, then you have to again first to use the time reversal property and then like that. So we have to follow the order and we have to just apply all the properties. We can do in any way. Okay, okay. The answer will come same only at the end. Now we will see some other question. Now we'll see questions based on like inverse Laplace transform. So access is given, that is s squared plus 12 divided by s, s plus 2 and s plus 3. So we have to find inverse Laplace of access. So we can decompose this fractional function in this way: a by s plus b by s plus 2 plus c by s plus 3, and we can find all this coefficient. So we can after that we can equate it with s square plus 12 divided by s plus 2 into s plus 3. So now we will see. So this can be written as s plus 2 s plus 3 divided by a will be multiplied with these two. So a into s squared plus 5s plus 6 plus b into s squared plus 3s plus c into s squared plus 2s. Now we'll equate all these coefficient. Now coefficient of s squared is 1 in the right hand side and left hand side, that is a plus b plus c, that is equal to 1. And for s that is 0, that is 5a plus 3b plus 2c is equal to 0. And also for like constant term, that is 6a is equal to 12. So a is equal to 2 here. Now when you substitute a is equal to 2, we will get two equations, that is b plus c is equal to minus 1, and also 5, 10. So 3b plus 2c is equal to minus 10. Now we can multiply above equation with 3 and subtract it. We will get 3c minus 2c, that is equal to c is equal to minus 3 plus 10, that is equal to 7. Now a plus b plus c is 1, so 7 plus 2, b will be minus 8. So we can write this whole term now like this: a by s, that is 2 by s plus b, that is minus 8 by s plus 2, and c is 7 by s plus 3. And now we can easily do the inverse. We know that for 1 by s, that is ut, so it will be 2 into ut minus, we can take ut outside, because like this also, like all these are right hand signal, so it will be multiplied with ut, so that the region of convergence also lie in the, like the intersection of region of convergence also match. So this will be 2 of ut minus, this will be 8 into e to the power minus 2t ut, and this will be plus 7 into e to the power minus 3t into ut. So this is our inverse of this function. So just we have to decompose in this, and we have to find the coefficient a, b, c, and find the value. We can take one more example. Like this time, this is of different term. Like earlier case, uh, all these are were having simple poles, that is s is equal to 0, s is equal to minus 2, s is equal to minus 3. In this time we will take some different kind of example. Let's suppose when axis is given 20 by s plus 3 into s squared plus 8s plus 25. So this time this does not have a simple pole. So in this case, how we will do, how we'll form the partial fraction, like we can write it 20 by s plus 3 into s squared plus 8s plus 25. This we can write it as a by s plus 3. Now here this is a quadratic form, so in the numerator we'll write in the linear form. So bs plus c divided by s squared plus 8s plus 25. Now we'll equate it with both the side and find the coefficient a, b, and c. So we will get a squared plus 8as plus 25a plus bs squared, and that will be 3bs plus cs. So 3b plus c into s plus 3c. So this we have to equate with 20. Now a plus b is equal to 0, and what are the term of s, that is 8a plus 3b plus c, that is also equal to 0. And what is the constant term? 25a plus 3c, that is equal to 25a plus 3c, that is equal to 20. So now we have to solve this equation. So from this we can write a is equal to minus b, and now instead of 3b we can substitute 3 minus 3a. So that we will get 5a plus c is equal to 0, and here we have 25a plus 3c is equal to 20. We can calculate it very fastly, but I am doing step by step. So just multiply it with 5 and subtract it. You will get 0, 5c minus 3c. That will be 2c. That is equal to minus 20. We will get c is equal to minus 10, and a will be 5a is equal to 10. Then a will be 2 and b will be minus 2, because a plus b is equal to 0. Now we'll substitute this. We will get a by s plus 3, that is 2 by s plus 3, bs plus c, that is minus 2s minus 10. So we can directly take plus here. We can take minus here and divided by s square plus 8s plus 25. So this is our access. So again, we can write it as 2 by s plus 3 minus, like this we can write it as 2 into, like this term we can write it as s plus 4 whole square, that is s square plus 16 plus 8s plus 3 square. So it is making some sense that we have to, in the numerator, we have to write in terms of s plus 4. So we can write 2 into s plus 4 divided by s plus 4 square plus 3 square, and this will be 2s plus 8. So we need like we need minus 2s minus 10. This will be minus 2s minus 8. So again we need minus 2 by s plus 4 whole square plus 3 square. So if we write here into 3 and divide by 3, then it will also make one easy inverse Laplace transform. So this we can do. So now for 2 by s plus 3, we know that that will be 2 into e to the power minus 3t. And for this, we know that this is the cos of 3t, and it is s plus 4 is there. So we will write e to the power minus 4t cos of 3t. So here it will write 2 e to the power minus 4t cos of 3t, and here again we'll write 2 by 3 sine of like e to the power minus 4t, because it is s plus 4. So e to the power minus 4t sine of 3t ut. So we have to do a small manipulation somewhere according to our denominator and numerator function, so that we can easily find the Laplace transform, because we know that for cos t, the Laplace transform is s by s square plus 1. For cos at, it will be a square. And for sin t, sin at, it will be a by s square plus a square. And when you do like, if you multiply with e to the power minus, let's suppose alpha t and cos beta t, then we can write it as uh, s, like in this s plus 4 is there. Okay, so we have to write s plus alpha. S plus alpha divided by s plus alpha square plus beta square. Similarly, for sinusoidal signal also, we can write e to the power minus alpha t sine of beta t, that can be written as beta square divided by s plus alpha square and plus beta square. So this was the one question. If you have any doubt, then you can ask. So next, we can take some gate questions. And also in control system, like there is one feedback connection that will be very useful. We know that like if the different systems are connected, it can be either cascaded or either it can be parallel or it can be feedback. So we'll see the transfer function for all this. So let's suppose if it is a cascade connection, this is very useful in control system course. So if let's suppose xt input is given and the different systems are cascaded like it is connected, interconnected one by one. So here our ht, the combined ht will be convolution of h1t into h2t into h3t. So simply we can write hs, that is transfer function, that is the multiplication of h1s, h2s into h3 of s. Now second can be parallel connection. Like in the last lecture I have done one example. In this, if x if the two system is connected in parallel, that is the summation of this is, now this is our yt, that is output. So yt is equal to xt convolution h1t plus xt convolution of h2t. So how we can find? We can directly write ys is equal to xs into h1s plus xs into h2s. So in this case, our ht is equal to h1t plus h2t. Simple, we will write hs is equal to h1s plus h2s. Now the next one, that is very important one, that is feedback connection. So in this, feedback is given from the output to the input end. Like if the input xt is given here, so now one feedback will be there, that is coming from the output end to the input. So let's suppose here it is et. So et will be xt minus yt convolution of h2t, because this is coming here, yt convolution of h2t. And also we can write yt as et convolution of h1t. Yt is equal to et convolution of h1t. xt. So when you substitute it, you will get et is equal to xt. Here we can write ys is equal to es into h1s, and this equation also we can write e of s is equal to x of s minus ys h2s. Now after that, when you eliminate es from these two equations, then you will get the transfer function that depends on hs, that is equal to h1s divided by 1 plus h1s h2s. This hs is equal to ys by xs. So this feedback connection is mostly used in control system, and there are lots of questions coming in GATE examination based on the feedback system. So now we will try to find the questions based on like final value theorem and initial value theorem. So if any students are watching this lecture on YouTube, then you can just write your doubt in the comment section. There I will reply, and also you can ask in the NPTEL forum. There multiple TAs are there to reply the doubt. A voltage having So this question is based on the final value theorem. Like in this question, a voltage have the Laplace transform that is given as this, and it is applied across a 2 Henry inductor having zero initial current. So what is the current in the inductor at t is equal to infinite? So we have to find I at infinite. So this we can simply find using the final value theorem, that is S tends to 0 SIS, like we have already seen here. When we have to find the final value theorem, f infinite is given as limit s tends to 0 s into fs, and also when f infinite is defined, and also all the pole of fs lie in the left side of s plane. So we can check this condition, whether this all this pole lie in the left side. So the roots will be minus b, that is minus 6, plus minus b square 36 minus 20 into 7 140 by 2a, that is 14. So it will be minus 6 plus minus that will be 104 by 14. So you can see that this is some imaginary term, but both the roots are lying somewhere like at -6, this one root and second root. Both the roots are lying in the left hand side of the S plane. So both roots are lying in the negative, like left side. There will be some imaginary value also, that is under root of -104 by 14. So this will be -104 by 14. So this is like a stable. So now we can easily apply the final value theorem. So the final value theorem when we will apply. So that will be, like we know that voltage is given as Li, V is equal to Li. We know this formula. So we have used that. So Vs is equal to, here I infinite will be S into Is. Okay. So I infinite will be Vs by L limit S tends to 0. So Vs is given as 4s square plus 3s plus 2 divided by 7s square plus 6s plus 5, and the value of L is 2 Henry, so 1 by 2. Now we can divide it both the, no, here S tending to 0, that's why we don't need to directly, will substitute S is equal to 0. So I infinite is equal to limit S tends to 0. When you substitute, you will get 1 by 2, that will be 0 plus 0 plus 2, that is 2 by 0 plus 0 plus 5. So that will be 1 by 5 ampere at t is equal to infinite. So on this concept, there will be a very tough question in network theory. So now we will solve question based on initial value theorem. So as we can see here, for final value theorem, just we have to apply this formula. And for initial value theorem, f0, that is equal to limit s of fs, simple only, but here s tends to infinite. So initial value theorem is only applied when the degree of numerator is less than degree of denominator. This important point you keep in mind before applying initial value theorem. So we can have one more question. If let me check whether the video is recorded or not. Sorry, why it is recorded. If Laplace transform of ft is given as 2s plus 1 divided by s square plus 2s plus 5. So we have to find and f infinite. Then find f0 and f infinite. So we have to find the initial value and final value. So first we'll apply initial value theorem. We will see degree of numerator is 1, that is less than degree of denominator, that is 2. So we can easily apply this. Always first check the condition whether we can apply initial value theorem or not. Because if you apply on the wrong, like if it is not applicable and if you apply, then you will definitely get a wrong answer and get a negative mark in the GATE examination. So here it satisfies the condition, so we can apply initial value theorem. So f of 0 is equal to limit s tends to infinite sfs. So that will be equal to 2s s plus 1 divided by s square plus 2s plus 5. Here limit s tends to infinite. So what do we do when s tends to infinite and such kind of things are there? We just divide by the highest order of s. So here it is s squared. So we will divide the numerator and denominator by s squared. Divide by s squared in numerator and denominator. So after that you will get limit s tends to infinite, that will be 2 plus 2 by s divided by 1 plus 2 by s plus 5 by s square. When s tends to infinite, then all the term which is having s in denominator will be 0, so that will be 2 by 1. So our f0 is equal to 2. Now for f infinite, first we'll check the roots of this, that is equal to roots is equal to minus 2 plus minus 4 by 4 minus 10 by 2. So this lies in the left side. So stable system, we can apply the final value theorem, that is f infinite is equal to limit s tends to 0 s into fs. So this will be limit s tends to 0 s into 2 into s plus 1 divided by s squared plus 2s plus 5. That will be 2s squared plus s divided by s squared plus 2s plus 5. When you substitute s is equal to 0, you will get this as a 0. So the final value will be 0 and initial value will be 2. Okay. In this way, we can apply the final and initial value theorem. We will see some more questions. I will take from gate book now. Question in the last 5 to 7 years. So we can take this question. This question was asked in 2015. So consider the differential equation dx by dt is equal to 10 minus 0.2x with initial condition x0 equal to 1. The response xt for t is greater than 0 is, there were 4 options as well, that is 2 minus e to the power minus 0.2t. Option B is so for this question, it is given that dx by dt, the differential equation, that is equal to 10 minus 0.2x. So we know that when the Laplace transform of xt is xs, then Laplace transform of dxt by dt that is equal to sxs minus x0. That is the initial condition. Here it is given. So this will be like when you substitute this, so this will be sxs minus x0. X0 is 1 here in this given question. And also like here you can see dx by dt, that is given as this. So Laplace transform of this will equate both this. So that will be 10 by s minus 0.2 into x of s. So what we have to find in this question, the response xt we have to find. So sxs minus x0, that is equal to 10 by s minus 0.2 xs. What we have done in this question, it is given that dx by dt is 10 minus 0.2x. So we have just find the Laplace transform of this. We got this. That is equation 1. Now we know that Laplace transform of dxt by dt is this. So this is our equation number 2. Now we have equated 1 and 2 because both are dx by dt. So 1 is equal to 2. We have got s into xs minus x0. x0 is 1. That is equal to 10 by s. Let's erase this, else you will get confused. 10 by s minus 0.2 xs. Now take xs as one in one side. So we will get s plus 0.2, that is equal to 10 by s plus 1. So our xs is equal to 10 by s into s plus 0.2 plus 1 by s plus 0.2. Now we have to find the signal xt. Okay. So the xt, and here is t is given greater than 0. That's why we have used the unilateral transform. In the question, every time see all the condition, then only apply the formula. Else you will come to the wrong answer. So xt will be when you do the Laplace transform of this. So 1 by s plus so let's multiply it with like 10 by, we can get write this as 10 by s, like we can multiply it with 5. So this term we can write it as 1 by if you s plus, or you can simply just write e to the power minus 0.2t plus this is 10 by s. We can just decompose this into the fraction. A by s plus b by s plus 0.2. Like this term we are finding first. So we will get as plus 0.2a plus bs by s into s plus 0.2. So this we can write it as a plus b is equal to 0, and the term of that is constant is 0.2a is equal to 10. So a is equal to 1 by 5, 50, and b is equal to minus 50. So we can easily write 50 by s minus 50 by s plus 0.2 plus 1 by s plus 0.2. So this we can write as 50 by s minus 49 by s plus 0.2. So this will be 50 into ut minus 49 into e to the power of minus 0.2t. So first we have calculated for this term and then we have added it. So this is our excess. Any doubt in this question? So we have to do here Laplace transform. We cannot write equal to like inverse Laplace transform. So the answer will be 50 minus 49 e to the power of minus 0.2t. So the correct answer is option number C. We will take one more question, maybe the last question for today's lecture. So we'll take one last question for this. That is also the gate question. Input xt and output yt of an LTI system are related by the differential equation y double dash t minus y dash t minus 6yt is equal to xt if the system is neither causal nor stable. The impulse response ht of the system is. So the four option given, no need to write the option, we'll directly find the solution of this and let's see what is the solution. So in this question, like input xt and output yt of an LTI system are related by this differential equation that is given as y double dash t minus y dash t minus 6yt equal to xt. Now if the system is neither causal nor stable, the impulse response st of the system is. So first we will find hs. So here it will be s square ys minus sys minus 6 of ys is equal to xs. Now the transfer function hs that is equal to ys by xs, this can be given as 1 by s square minus s minus 6. So we can write s square minus s minus 6 as s minus 3 and into s plus 2. Minus 3 plus 2 is equal to minus 1. Yes, correct. So we can write it as s minus 3 into s plus 2. So what is the value of a and b? That is a plus b is equal to 0 2a minus 3b is equal to 1. A is equal to minus b, so that will be minus 5b is equal to 1. So b is equal to minus 1 by 5 and a is equal to 1 by 5. So we can write it as 1 by 5 by s minus 3 minus 1 by 5 by s plus 2. Or here we can write like this, plus minus. Now we will find the, if the system is neither causal nor stable, then the ROC will be the left hand side. So like there are two roots, s is equal to 3 and s is equal to minus 2. So if j omega lie in that, then the system will be stable. So region of convergence will be this side. Okay. So region of convergence will be the left hand side. So this means that here we can write minus and minus, because this will be like this will be depending on u of minus t. So we will take this inverse Laplace transform in terms of u of minus t, because these signals are left-handed signals. So ht is equal to minus of 1 by 5 e to the power 3t u of minus t plus 1 by 5 e to the power minus 2t u of minus t. So understood? And region of convergence will be, that is sigma is less than minus 2. Any doubt in this question? So here region of convergence played a important role to find the answer. Now we can take some more question. Let xt is equal to alpha st plus s of minus t with st is equal to beta into e to the power minus 4t into ut, where ut is unit step function. This is also previous year gate question. If the bilateral Laplace transform of xt is xs is equal to 16 by s square minus 16 minus 4, the region of convergence is from minus 4 to plus 4. Then find the value of beta. So in this question, it is given xt is equal to alpha st plus s minus t. Here st is separately given like this, where ut is the unit step function. If the bilateral Laplace transform of xt is 16 minus s square minus 16, then we have to find the value of beta. So first we'll write xt and we'll find the Laplace transform of it. So alpha into beta into e to the power minus 4t ut plus s of minus t. So that is beta into e to the power 4t u of minus t. And in this question, it is given that xs is equal to 16 by s square minus 16. Okay, so and the reason of convergence, that is real part of s is minus 4 to 4. So we can write it at 16 by s plus 4 s minus 4. When you decompose it, you can write as a plus b is equal to 0 and minus 4a plus 4b is equal to 16. So this means b is equal to minus a 8a is equal to 16. So a is equal to minus 2 and b is equal to 2. So we will get minus 2 by s plus 4 plus 2 by s minus 4. Here we will get minus 2 by, so like there are four, like there are two roots. One is at minus 4 from the first one, from the second one s is equal to 4. But the reason of convergence is minus 4 to 4. So this means, sorry, this is plus 4. So this is plus 4. So this is minus 4. This is the first one, this is second. So the first signal, the region of convergence is the right hand side. So here we will write minus 2 into e to the power, write with blue pen, minus 2 into e to the power minus 4t ut. Okay. And the second signal whose root is plus 4, that is the left hand side. Okay. So here we will write minus 2 e to the power 4t u of minus t, because this is left side signal. Now, when you equate this with our xt, that is given as alpha beta e to the power minus 4t ut plus beta into e to the power 4t u of minus t. So, what will be here? Alpha into beta is equal to minus 2 and beta is equal to minus 2. We have to find the value of beta, that is equal to minus 2 here. So got this question? If you have any doubt, then you can ask. So today we will end up here only. And the student who have missed this tutorial session can watch in the YouTube. And in the next week, we will study about Z transform at the same time on Monday, 5 to 7. So please join that day. And this link for this YouTube will be uploaded on the, that will be given on the NPTEL portal in the PMRF section. So today we'll end up here only. Thank you so much for attending. Thank you everyone. Bye.